All right, you guys have any questions on the previous two homework?
62.
62. Let me just push pause on this.
3-5.
What happened to 3-4?
It's just identities. If you guys want to go through them and do them, you can. But it's just checking identities with all the trig functions we've used. The trig identities. Okay. So here we go. So inverse functions today. Inverse trig. Now, really quick, I'm going to push pause. Here we go. So 3, 5 is inverse trig. Inverse trig. So, first off, do you guys remember what an inverse is?
Something to the -1.
Okay, that could be the case. So let's just do something that you feel comfortable with, like y equals x plus 4. Right? It's a very just basic equation of a line, right? What is its inverse? Remember, the definition of inverse is that the inputs become the outputs become the inputs. Right? So the outputs become the inputs, which x becomes y, and y becomes x, and vice versa. And then we solve for y. So his inverse, which we could call this f of x, by the way, his inverse would be f's inverse of x would be x minus 4. Agreed? I would see how we just subtracted the 4 over to the other side, right? Does that remember that? Well, you're doing the inverse trig functions. So here's our graph. Y equals sine of x. This is what we learned last unit, right? We did this graph really quickly. Here's what it looked like. I'm going to do it quick. Okay. This is 1. This is -1. We go here. Right? Now, obviously, this is just one cycle of that sine graph, though. It goes on forever. Correct? So now notice I want to show you guys what would its inverse look like. Well, the x values become the y values. So this goes this way. This is pi halves. Pi, here, let me scroll down. Pi halves, pi, 3 pi halves, 2 pi. And notice we had the y's become the x's. So we had 1 and -1. Agreed? Here's what the graph looks like. Is everybody there with me?
What's the inverse right there?
That would be its inverse. So here, this is y equals sine of x was up here, right? So therefore, if I'm going to go its inverse, we could call him f of x once again. This would be x equals sine of y. And then how do we get rid of the sine to get him to the other side? Inverse sine of x equals y. This is also another name. I also use what we call arc sine. I like to use arc sine because then some people get this sometimes confused with cosecant. Is this the same thing as cosecant because we see the -1? It's not. And that's why I don't like to use that, just so you don't think it's just the reciprocal, right? It's its inverse. Does that make sense to everybody? Now, if you guys can recall, is this inverse a function?
No.
No, because vertical line test doesn't pass, does it? So where do we start having issues? What value of y do we start having an issue? Right here. As soon as we get past pi halves, we have issues, don't we?
Mm-hmm.
So really, to be honest, I could continue and go negative pi halves here, and it would be at -1. And notice if I just had this graph here from pi halves to negative pi halves, 1 and negative 1, would that pass the vertical line test? Yes. So this is the most important thing you're going to have here. Now, we just talked about, I want to check one more time. So, sketch graphs of the inverse trig function. That's this right there. We just sketched it. So this is the important part for the inverse trig function is right there. This is what you need to know. This is f of x equals, okay, at 1, I'm at pi halves. 0, I'm 0. Negative pi halves, I'm at negative 1. Make sure it's because it's a curve, right? That'd be its graph. So what's its domain of an inverse? And that makes sense because that's the lowest value sine can be and that's the highest value sine could be, right? So therefore, the domain, the values I can plug in there have to be between negative 1 and 1. If we're outside that, we can't have a sine value of it because it doesn't make sense, right? Okay, what's its range? So that's why on your calculator, that if you did the arc sine of an angle, it'll always put you an angle in quadrant 1 or quadrant 4. Because the angles come from negative pi halves to pi halves. Negative pi half starts down here to pi halves here, and those are all the angles that are possible that it'll give you, right? Why doesn't it give us an angle in quadrant 2? Because that's also positive. Sine would be positive here and here. Does that make sense? So therefore, that's the only place that gives us a positive and a negative. Now I'm kind of curious. Like I said, I'm kind of curious on how in depth they go on graphing. I think that's as much as you're going to have to do. They might shift you, but I just don't think they would. There's no point in shifting that graph. I don't even like to graph these things. There's really no point in them, to be honest, except to show you what's really where the answers come from. Okay, so let's hurry and do cosine. So here's cosine's graph. I've been getting the sniffles. I've been feeling like I've been blowing my nose through my mouth for about a damn month. How'd you do in your basketball game? Have you played Josh yet? No. Or you guys are in different leagues, you said?
Yeah, right after I started something. I think he did really well.
Yeah? Has he been playing a lot? Does he play a lot?
Sometimes he gets no call. Sometimes he gets. He started like one.
Was that senior night? All right, so that's cosine, and once again, we all understand that this is one cycle of it, and it can continue on, correct? So now let's do its inverse. So we're going to take those points and flip them on its side. So we get this graph. Agreed? Let you catch up really quick. That's pretty. Yeah, I try. Oh, did you do that right though? Because it starts over here. It goes that way. Because it starts on 1, right? Not -1. Okay, but once again, this is still not a function, right? Agreed? Where do we stop being a function at?
Pi.
Pi. Up until pi, we were fine, correct? Notice, ladies and gentlemen, though, unlike sine, that is its function just from zero to pi. Okay, so what's its domain? What's its range?
0 to pi.
Yep. So all inverse cosines will give you an angle between 0 and pi. And that should make sense because in quadrant 1 and quadrant 2, right, they are both, quadrant 1 gives cosine a positive angle. Quadrant 2, cosine gives those are negative values that would give us an angle, right? What about 1 and 4? Why is it not 1 and 4 like sine? Because cosine's positive here and he's positive there, so I wouldn't have the same angle, would I? Does that make sense? Whereas quadrant 1 and quadrant 2, I have a positive angle, a positive result, and a negative result. That's why it's here.
Why did you do it in that? So this, you said it was this one and this one, but it's this one and this one. Like you said it was like positive, negative.
So the domain, so you're talking on the inverse sine, domains from -1 to 1, those are the x values that you can have. You can have values. If you, like, for example, we'll get to it in just a minute, but like if I said, okay, sine of x is 3/2, right? Is that possible? Is there an angle out there that'll give me a sine that gives me 3/2? No, there isn't. So that's what I'm saying. When I take the arc sine, this x value better be between 1 and -1.
So this one has a
It does too, and that's what we just talked about right here. At the domain's -1 to 1. Because this is
like it's the top.
Yep, it's the
But
top
with the
two.
other one, it was the
Yep.
side one.
And the reason being is because sine is positive here and positive here.
Yeah.
Right? So it doesn't give me all values, because what values could I have? All values between 1, that gives us these values.
Mm-hmm.
And I need values of -1. This quadrant doesn't. That quadrant does. And we're looking for back-to-back quadrants.
They have to be next to each other.
Yeah.
So what about tangent? Because
that's what we're going to show right in a minute.
tangent is only cross.
It's actually positive and positive, but they're going to use these ones as well, because we'll show in just a minute what their graph looks like. Okay, is everybody with me there? Yes, no? Okay. So, and then I don't think they're doing tangent, but we'll put it this way. Hold on, let me just make sure. Hope they do it, so let's try and do it. So here's what tangent would look like. Once again, if you guys recall, I'm going to go over here because it's going to make more sense. Here's its tangent graph. Right? Is everybody there with me?
That one's up at 1.
Uh-huh. So here's what its inverse tangent looks like. And notice, so what's its region that makes it a function? Anywhere between negative pi halves and pi halves, right? That'd be our range. So this is the arc tangent. And if you think about it, that gives us our domain here is negative infinity to infinity. And that should make sense because I can have any result for a tangent. There's no restrictions on that, right? But the range is negative pi halves to pi halves. Okay?
Because that's the whole.
Yeah, that's all. That's the part that connects. Now, technically, quartile 1, not quartile 1, I've been doing quartiles in my other ones. Quadrant 1, tangent's positive. Quadrant 4, tangent's negative, and notice, hence why we're using values between negative pi halves and pi halves. Now, the question is, why don't I use numbers over here? Because tangent's negative. And the reason being is we don't want to go past the asymptote. Because at pi halves, tangent's undefined. Hence the asymptote. And that's what I'm assuming is they want consistency. They want a fluid graph.
It's just regular tangent, so not inverse.
Yep, and this is regular, but what the reason why on the inverse tangent they don't go past pi halves is they're looking for a continuous graph. So where is the continuous graph work for? Negative pi halves to pi halves. Does that make sense?
Yeah.
All right. So now, how do I use this? I don't know what they're going to be doing on the graphs, guys. I really don't. It says it in there. I really wish I got just Joe what the hell I'm doing. I did send the email, but I don't know yet. Okay, so here we go. Y equals negative root 3, excuse me. Let's just do that. Y equals tangent inverse. So that's the inverse tangent, or you could see the arc tangent. They do mean the same thing. Negative root 3 over 3. So what is this asking us? Does anybody know? What is this question asking us?
Where is the tangent that way?
So we're looking for an angle. When I'm doing an inverse trig function, an inverse trig function will find an angle. Okay, so you might want to write that down. Inverse trig functions find angles. Now, that angle has to be within its restrictions, right? And then the restriction for arctangent or inverse tangent, remember it's between negative pi halves and pi halves. That's its restrictions. I love how you don't use the back sides.
I go back to.
Oh, do you?
Nice.
Nice. Okay, so then we sit here. These are going to be most of the time unit circle questions. Okay.
I want to be able to do my homework with it first.
Nice. So then we say, okay, where is tangent root 3 over 3? So really, let's just think about it really quick. Here's my unit circle, just so we can have the idea. We have 30 degrees, which is pi 6, which is root 3 over 2 comma a half. We have 45 degrees, which is pi fourths, which is root 2 over 2, root 2 over 2, right? And then we have up here, we have pi thirds, which is 1/2 comma root 3 over 2. Agreed? So what would be the tangent value of pi 6? Yep, it'd be 1/2 over root 3 over 2, which comes out to be 1 over root 3, which is root 3 over 3. But we need the negative. So we're not in quadrant 1, are we? We're in quadrant what? 4. So we need this one, which is pi 6th away. So do we say 11 pi 6th?
Or negative.
We don't say 11 pi 6th because there's 11 pi 6 between negative pi halves and pi halves. No. So what is the angle? Negative pi 6. First off, let's really quickly just look right here. So the tangent of pi 6 is root 3 over 3. What's the tangent of pi fourths? 1. What's the tangent of pi thirds? Root 3. So just so you know, because those ones we don't see on the unit circle, you actually have to do a little math to find those. But just to understand, those are the three values you can have for tangent, except for obviously 0 and undefined up here. Does that make sense? Should we try another one?
Wait, so that's the answer?
Is pi 6.
Wait, why is it?
Negative pi 6, excuse me, negative pi 6.
Why isn't it normal pi?
Because pi 6 was root 3 over 3, and notice the question was negative root 3 over 3. With me there? Okay, so let's do another one. So let's say, what is the y value if the inverse cosine, once again, could see it as arc cosine, just depending on each book. Some books write it one way, some write it the other. Understand they are the same if you ever get further and you see differences. So negative root 2 over 2. Negative root 2 over 2. So what angles was cosine available to use?
The top one?
0 to pi, right? So therefore, as you said, the top two quadrants. My angles are here, huh? But because it's negative, which quadrant is this going to be in?
The second one.
Second quadrant over here, right? And where is my y value? Negative root 2 over 2. I mean my x value? 3 pi fourths. How are we doing? Feeling comfortable? So just be aware, what about cosecant? What angle would he be between? Like inverse cosecant. What angles would he be between? Same as sine, still negative pi halves to pi halves, right? How about secant?
Same as cosine.
Same as cosine, so 0 to pi. Sorry, these should be brackets. I don't know why I didn't do brackets. And cotangent, negative pi halves to pi halves. And these ones should be parentheses because I can't be at negative pi halves or pi halves because they're undefined technically, right? Does that make sense to everybody? You guys ready to start thinking like a jinkin? Huh? You were already? Good. This one I'm going to make you really deeply think. Deeper. Deeper, deeper. I'm trying, Dad. Good old joke from back in the day. Nothing. It was just a horrible, sick joke. Babysitters.
I was trying not to think of it that way. I was hoping there was something else.
No. Sorry. I'm a person of bad influences. Okay, I got a question for you. Okay? Let me ask you guys this question. If I had an inverse cosine of a cosine of x, what is that answer going to be?
What?
So let's really see what this is asking us. What will this give us? It'll give us an answer between what?
0 and pi.
No, not cosine of x. The angles will be between 0 and negative infinity to infinity. I can use any numbers I want, right? Any angles, correct? But what will the answer be between? -1 and 1. Agreed? So let's put it in context. Let's do this. How about this? Inverse cosine of 7 pi 6. Okay? So let's just ignore the inverse cosine on the outside. What is cosine of 7 pi 6?
Is
Unit circle again, right? Thinking about it.
The first value after pi,
Uh-huh.
and you circle.
It would be -√3/2. Okay? Sine would be -1/2 there. So this would be arc cosine or inverse cosine of -√3/2. So what is this question asking us?
cosine -√3/2.
Where is, what angle is cosine -√3/2?
Which is 7.1.
Which is 7 pi 6, right?
So,
Yes, it is. But is 7 pi 6 within its restrictions?
No.
No, remember, what's our restrictions? Our angle has to be between what? 0 and pi, right? So who is also an angle that gives me -√3/2? That's within 0 and pi. 5 pi 6. So this is what I was trying to get at. If at here, x is already between pi and 0, what's the answer going to be? It's just going to be x, huh? But if x is outside of that region, you're going to have to find another angle that has that same result within the restrictions. Does that make sense what I'm trying to say by that? Because once again, 7 pi 6 is outside of what arc cosine can give us. Arc cosine can only give us answers between 0 and pi. This is our thinking. This is the deeper part. Okay? 0 to pi. But 7 pi 6 is outside of that, so I have to find another angle that would be -√3/2, which is the 5 pi 6. Does that make sense to everybody? So once again, though, let's show you what I mean here with 0 to pi. So let's say if I said, all right, here's the inverse cosine of pi 6.
cosine pi 6 is between
√3/2.
3/2. So then,
So what's the inverse cosine of √3/2? Within 0 to pi. Pi 6. Now notice once again, this angle was within our restrictions, right? Between 0 and pi. So therefore, what does the result come out to be?
why does it want you to find what it's equal to? It literally gives you it, but then you have to find it.
Exactly. But that's the thing that we're trying to talk about here, coming back over to here. Is notice, did I exactly get the same angle?
Or is it from a different form?
Because it's in a different quadrant. This guy's in third quadrant. He's outside our restrictions. So therefore, I have to find an angle that is equivalent to him that gives the same value in a different quadrant that works.
So, just wait 1 second.
Does that make sense what I'm saying?
Yeah.
Do you see the difference within the two?
Mm-hmm.
The first one was outside of 0 to 2 pi, so I had to find an angle within that. But where the other one, because the angle is within the restrictions of 0 to pi, then it's just what it is. Agreed? Some people think that an arc cosine and a cosine just get rid of each other all the time. They don't. Only if the angle is within the restrictions. Do you have a question, Carter?
No, I just didn't know the research. So, you know, arc cosine, the cosine, or the sine, arc sine, and the sine, get rid of each other
If it's within its regions. Yes, but if the angle is outside of its regions, does it? No, because you then have to find an angle that is within those regions. Does that make sense to everybody? This is a big lesson today, actually. Okay, here we go. So this is the next problem. This is another great question. Here we go. So let's say I want you to find the sine of an arc cosine of 2/5. Now, is this something that we know on the unit circle? Is 2/5 on the unit circle?
No.
Okay, so what will this give us though? What can we always do? This is basically saying the same thing as this. This is saying this. Agreed? It's saying what angle, when I take a cosine of it, is 2/5. What can I always build with trig functions? Okay, what triangle or quadrant am I going to be in? Remember, arc cosine can only put us in quadrant 1 or quadrant 2. Is this in quadrant 1 or quadrant 2?
What do you mean?
Because it's positive.
Because this is a cosine value coming out positive. Remember, this is giving us an angle. It's in 1. Why is it in 1? Because of our positive. What if it was negative 2/5? Where would I be putting this? In quadrant 2. Does that make sense to everybody? So I'm drawing that triangle. Here's 2, here's 5. Then we do a good old Pythagorean theorem. It won't be 3. So this is, remember, this is 25, this is 4, because I'm doing Pythagorean theorem backwards. Square root of 21. With me? Okay, so what angle is this, guys? Do we know what angle this is? We're going to call him theta. But here's theta right there. So we're going to say, okay, well, this is sine of theta. What is sine of theta?
Wait, why are we saying this in a theta?
Because really, this is coming out here, this idea right here. That's asking us what angle. Do we know what angle that is? No, we have no idea. So I'm just going to call that angle theta, which we did here, and we drew the triangle that corresponds with him. Does that make sense to everybody? So then I come down here and I want to find the sine of that angle, which we called theta, right? And the sine of that theta, which is right here, is opposite over hypotenuse. So that's where we're at. That is the answer. You guys want another one of them? Oops, I'm in the highlighting. Okay. What quadrant is this in? 4, because once again, my restrictions have to be in quadrant 1 or quadrant 4. And because it's negative, I'm in quadrant 4. So sine is -3. This is 5. What's this?
4.
4, because good old Pythagorean theorem, right? Tells me this is a 3, 4, 5 triangle, and he's positive because the x value is positive in quadrant 4, correct? And then once again, what is this telling us? This is telling us this angle is theta, right? So we'll put theta here. So what is this really telling us? We're trying to find the tangent of theta, right? And what is the tangent of theta? -3/4. That would be it. You see how we're thinking though, because this is asking us. Remember, this is saying, tell me an angle. We don't know the angle. Okay? Excuse me. Because we don't know the angle, we're just doing a triangle, because every trig function, can, if we have a result, can give us a triangle. Okay? Then I'm taking a tangent of that angle, which I don't know, but because of the triangle, I do know ratios of that triangle. Okay. All right, ready for a harder one? Do we have it vice versa, Willies? Oh, yeah. Okay. So let's do it this way. Can anybody tell me this idea? Is this different? Because remember, when we did this, of some type of angle, we couldn't always say that was just theta, right? Agreed? Because what if theta wasn't within its restrictions? Then we'd have to find an angle that was within its restrictions, correct? Agreed? But here, what is this telling us? This is some angle, right? We're calling him theta. We're going to take the tangent of that theta. Well, what is it? You got it. Say it louder. It is just 3/4. Because the arc of that is already there. I mean, I could do exactly what I just did on those previous problems. Okay, we're in quadrant 1, theta, 3/4, this is 5. Now I'm taking tangent of that theta, which is 3/4. So this is what I was trying to show here. How about taking a tangent of its inverse? What will that always be? It's whatever he is. Now, will the inverse of a tangent always be the x? No, because it's the angle's got to be within that restriction, right? Okay. You guys ready? What does this tell us right here? The black line, what does that tell us? Arc cosine or inverse cosine of 2/3. What is that giving us? It's giving us an angle, right? Technically, correct? Do we all agree when we see inverses of things that's an angle? Well, we don't know what that angle is because that's not a unit circle question, is it? Is 2/3 on the unit circle? So we don't know that angle, so we're going to call him alpha. Okay, do we know what this is telling us? It's an angle again, right? But is it the same angle as what we had? Not necessarily. So we can't assume that it is, so let's call it beta. So really what I have here is secant of alpha plus beta, which is a sum and difference formula, which this is 1 over cosine of alpha plus beta, which is 1 over cosine of alpha cosine of beta minus sine alpha sine beta. Everybody agree with that? Probably need to draw what? Triangles. So let's do alpha's triangle. Which quadrant is he going to be in? Because it does say arc cosine of 2/3. Quadrant 1. Coming from the top right here.
So do 2/3.
So we're going to do 2/3. This guy's root 5. That's alpha's triangle. Beta's triangle will also be in quadrant 1. And his is 2/3. So this guy over here is root 5, right? Everybody there with me? Yes, no? Oh, sorry. Just stretching. You're like, yeah, Okay, so here we go. We're going to do this stuff right here. Right? So we're at 1 over cosine of alpha. Who is our cosine of alpha?
Cosine of alpha is 2/3.
2/3, very correct. That was horrible.
And then cosine of theta is square root of 5/3.
Square root of 5/3
Plus or minus
minus
square root of 5/3
square root of 5/3
times 2/3.
And then,
So that's just canceling itself out.
and then it's
The
1
answer
over
is
0
1.
under 5.
That's lame. Is it always going to be undefined?
No. You want to do one that's not?
Yeah.
But it's still the same process, right? Just so happened that this stuff, because they have different ratios just at different spots, right? Let's see. Okay. So once again, we're going to call him alpha. We're going to call him beta. Let's go ahead and draw our triangles first. What quadrant is the arc sign in?
1.
Quadrant 1. How does that kid sleep in so damn much? Does he have a job he stays up late, or is he just playing your guys' damn video game?
I don't know. Or he's just super lazy and he's like, he just goes to bed and wakes up and decides to even if I need to sleep, because I get 8 hours. So like from school I play still up there.
Yep, I agree. Today I had a hard time. Beta's over in quadrant 2, right? Why is he in quadrant 2? Because it's a negative, and cosine's inverse puts us in quadrant 1 or 2, right? So this is negative 5/13. And by the way, if you don't know, that's 12. Go ahead and do the sine of alpha plus beta. This is Mr. Roberts. How are you? Good. Hard, yep. Was this the one about? There's so many emails I've been getting. I'm sorry. Help me out a little bit. Yeah, okay, it is him. And then you talk to Mr. O'Connor, and then you can see what he's correct? I thought it was him, but I'm like, I've been having so many, I can't remember. Okay. I just need him to come up and visit me classroom, and then we're going to talk about how it's going to happen. I got to look at what he missed and things like that on the summer program, so I know what he needs to pick up. Is it just Canvas, or is there other assignments, things like that? And so I can look that up with him. But I even talked to him yesterday to get something go over that exact date time. Okay. No problem. If you'll just text him and say, hey, when you have time, then we'll just do it. Okay. All right.
Did you get like 0.5 or something? Or 33?
All right. So that's sine of alpha plus beta, right? So that's a sum and difference formula again, correct?
Yeah.
Right? So, excuse me. So this is sine of alpha plus beta. So with that being said, that's sine of alpha, cosine of beta, plus sine of beta, cosine alpha. Right? Okay, who's the sine of alpha? 3/5. How about cosine of beta? Plus sine of beta. No. 12/13, right?
Oh,
because it's beta. Cosine of alpha. So I get negative 15/65 plus 48/65, which is 33/65, and that can't be reduced. So there it is.
Yeah.
Now it does look like they do a few graphing. I don't really understand why we graph, but I think you guys could do that. The next part I want to get into though is this. Okay, here we go. Can we change this to a secant? Okay. What does that tell us? An angle. I want to get that in your head. Anytime you see an inverse whatever, that is an angle, right? So let's go ahead and draw that angle. Well, arc sine, I don't know if it's positive or negative. Do you guys know what x is? So we're just going to assume he's in quadrant 1. Here's angle. But this guy's 1 and this guy, excuse me, x and this guy's 1 because this is x over 1. Would you guys agree with that? The angle is x over 1. How would I find this side right here?
That would be 1 minus x squared.
1 minus x squared underneath the square root.
Yes, that.
Right? Okay. And then, there it is. So now this is asking us to find the secant of theta, basically, then, huh? And what is the secant of theta?
It's 1 over cosine.
1 over cosine, and cosine is adjacent over hypotenuse, so therefore hypotenuse over adjacent. Do we like that answer?
No.
1 over.
And so cosine is, this is hypotenuse over adjacent, right? Yep. And adjacent to 1 minus x squared underneath the square root. So then I rationalize. And there he is. Okay. Can I see your problems? I just want to make sure they're adequate problems. How about you read them to me?
Okay.
Can you go back?
Yep.
2,
2, okay,
3,
okay,
5,
good,
7,
nice,
10,
good,
12,
yep,
13,
good,
15,
loving it,
19,
yep. Okay,
20.
this one really quick. This is asking us how we put this in our calculator for inverses. How do you put, if I ask you to find the inverse of 0.822, how would I find that?
Second, it should be on the side.
What mode should I be in?
Well, you should be in
Radian.
radians.
They like radians, right? So you should be in
Unless it
radian
says
mode.
degrees, you're in radians.
Yep. So then we just put that in and plug away. What if it was cosecant inverse of 0.822?
Then it would be 1 over.
1 over inverse sine of 0.822. Does that make sense to everybody? Okay. 19.
23,
Love it.
27,
Good.
30,
Okay.
31,
On it like blue bonnet.
32,
Okay.
35,
Loving it.
40,
Loving it again.
44,
Okay.
47,
Okay.
51,
Okay.
55,
Whoa. Okay. Okay. All right.
63,
63. Okay.
64,
Oh, we're gonna have to look at 63. Okay.
75,
Okay.
76,
Okay.
80.
Okay. All right. Let's look at these ones really quick. I'll do number 61 since that wasn't one of our problems. So we have inverse sine of x minus 1 equals pi halves. So how do I go about this?
Wouldn't that be x minus 1 equals sine of pi halves?
It does, because I can flip it back and forth, right? Here's its inverse. That means that sine of pi halves equals x minus 1. It does, because this is, remember, like, this is our x and this is our y. What would his inverse be? Sine of y equals x, right?
Okay.
Does that make sense? Everybody there on that? They're
Okay,
inverses.
So, this, 1.
So therefore, what is sine of pi halves? 1 equals x minus 1, and then we add x's to. Not too hard to do those, right? Okay, that's it. You guys have the homework via the paper, right?
Mm-hmm.
Okay.